Alright guys, today we're going to solve quadratic linear systems algebraically. Alright, first I'm going to do one graphically, just to review what we did yesterday. Alright, so I'm going to graph the first equation, which is y equals x squared plus 2x plus 1. Alright, go to the graph first, see kind of where it is. Alright, slightly to the left of 0. So we're going to use some negative values for x and some positive values for x. All right, so I'm going to go from -4 to 2. All right. What you might want to do is pause the video, plot, plug this in the calculator, plot the points, and then restart it. All right, so I'm plotting these points from -4 to 2. All right. So this is my quadratic. Alright, then I'm going to plot my linear equation. Now, remember, if you could plot the linear equation using slope-intercept, that's going to make it go a lot quicker. This is my slope, which is 2 over 1, which means I'm going to go up 2, right 1. This 5 is my y-intercept. This is where I'm going to start. Alright, so I'm going to go back to my graph. I'm going to start at 5. And I'm going to go up 2 and over 1. All right, I ran out of space, so I want to go backwards. So I'm going to go the opposite of up. I'm going to go down 2. The opposite of right, I'm going to go left 1. Down 2, left 1. All right. I crossed the quadratic again, so I pretty much have enough points. And I'm going to connect the dots. All right, remember, the solution is where these two cross. So they cross up here and down there, all right? Which is at -2, 1 and 2, 9. These are our solutions. All right, but what I also want to point out is that let's say you didn't have graph paper. You could figure out these two answers by plugging in both equations at the same time and go into your table of values. So I'm going to go back to y equals. I already have the first equation in. So I'm going to go back to y2 now, and I'm going to plug in the second equation, 2x plus 5. All right, and my solution is where they cross. So if you look, it crosses once a little bit to the left of 0 and once a little bit to the right of 0. So I'm going to go to my table. I know these things cross when the y values are the same. So if you look at -2, 1, see how both y values are 1. That's one of our solutions. And at +2, our y values are both 9. So I'm going to write these coordinates down. All right? So you could see, point this out so you could keep this as notes to follow. So at -2, they were both 1. At -1, the first y was 0, the second one was 3. And then at 0, it was 1 and 5. See how they're not the same? At 1, it's 4 and 7. They're not the same, but at 2, they're both 9. So this is our solution, 2, 9 and -2, 1, because the y values are the same. So when the two y values equal each other, that's your solution. So that's what we're going to use to solve it algebraically. It's when the y values are equal. So we're going to take our two equations, our expressions for these equations, x squared plus 2x plus 1, and we're going to make it equal to 2x plus 5. Because when the two y values are equal, that's your solution. So this is one y value, and this is the other. We're going to make it equal. So x squared plus 2x plus 1 equals the other equation, 2x plus 5. So step 1. We're going to set the two equations equal to each other. Step 2. We are going to put it in standard form. Make it equal 0. All right, so that's what I'm going to do next. So what I'm going to do is I got to make it equal 0. So I got to get this 2x and this plus 5. I got to get it out of here. So I'm going to subtract 2x on both sides. All right, I put it under this 2x because they're like. I'm going to subtract 5 on both sides. 2x minus 2x is nothing. It's gone. 5 minus 5 is nothing. So on the right side, it equals 0. On the left, I'm going to bring down the x squared. I'm going to combine 2x and negative 2x. That's nothing. 1 minus 5 is negative 4. Step 3. Factor and solve. Right? Or graph it. All right, if you're comfortable, I'm going to leave that there for a second. If you're comfortable enough factoring, I would try to factor it because you're trying to show your work. All right? If you struggle with that, you could graph it. I'm going to show you both ways. So I'm going to factor. All right, this is a difference of 2 squares, remember? 4 is a perfect square. What times itself gives us 4? 2. Right? It's a minus, so I got x minus, bring it down. It's got to be a negative 4, so they have to be different signs, x plus. 2 times 2 gives me 4. Now remember, your answers, they're going to have the opposite signs. So if the fact is x minus 2, the answer equals x equals 2, right? You got to bring the 2 to the other side. If the fact is x plus 2, you got to bring the 2 over. Your answer is going to be negative 2. So these are 2 x values. And you may not have noticed, but these are the same 2 equations as number 1. Notice how I got the same x values as before. Now, if you're not comfortable factoring, what you could do is you could plug this in the calculator. Before you plug it in the calculator, though, it's got to equal 0. So I could type in, I'm going to clear out this other stuff, x squared minus 4. And graph it. And my zeros are where it crosses the x-axis. It crosses at negative 2 and positive 2. All right? All right, we're almost there. Last step. We need to plug in the values of x to find the y values. All right? Plug in the value of x to find the y value. All right, so we're going to do this separately. Ready? On this side, I'm going to go back again. All right, you can plug it into either equation. So I'd say the second one's easier. Y equals 2x plus 5. We're going to plug in the 2. So y equals 2 times 2 plus 5. 2 times 2 is 4. 4 plus 5, y is 9. So when x is 2, y is 9. That's our first solution, 2 comma 9. All right, I'm going to do the same thing, except this time I'm going to plug in negative 2. So I'm going to take that same equation. You could use either one. I'm going to plug in the negative 2. 2 times negative 2 plus 5. That's negative 4 plus 5. Negative 4 plus 5 is 1. So now our other solution is negative 2, comma 1. All right? And again, you could check it by doing what we did for number 1. You could plug in both equations and then go to the table and see where it matches. All right? All right, I'm going to stop this video and do the next example in another video. All right, so look this over. All right, and we'll see you on number 3.